attempted to draw a circle between two objects. There are no signs like that. No, you didn't.
Like, I mean, the graph. Like, when you add 10.
Okay, enough. I know you all know what an angle is, but sometimes mathematical concepts are hard to put into words, and I think that this is one of those. I'm just interested in hearing that. Just the first one. So what is an angle? Caleb, what do you think an angle is?
Oh, I know the 9-letter word.
Just a minute. Yeah, Caleb.
It's like a
I like you're gesturing, right? So
yeah.
this is an angle. And between two, is that right? Two rays? Are we good with that?
Yeah.
Okay, so you're right there. Now, is a measure actually part of the definition of an angle? Well, that's more of an adjective, right? It describes the angle. If it's between 0 and 90, then the angle would be acute. If it's between 90 and 180, if it's more than 180, is there such thing as an angle that's more than 180?
So.
Yeah.
Wait, yeah.
Well, we shall see today. Dun, dun, dun. Yeah, thank you for the introduction to that definition. Oh, so definition, if it's so if I have two rays and this is a ray, isn't it?
Yes.
So if I just kind of measure how far apart these are, then that's an angle, is that right? Oh. Yeah, what's that?
It's like if the two things, if they were connected,
Mhm.
it's like if you drew like a circle, how complete the circle would be between them.
So you need a circle for an angle?
Yes. Yeah, it's like a part of a circle. So the angle,
Okay.
how much you can draw the circle is like the angle.
Ah, okay. That may be the measure of the angle, like how big that is. And circle could help. Okay, so I could draw a circle. Yeah, yeah. Yeah, they have to be intersecting like this, right? So that's an angle. Uh, have the same, what's the word I'm looking for? Endpoint, yeah. Every ray has, it starts at, for some reason, something called the endpoint, and then goes in a particular direction. That is a ray. So the definition of an angle is just two rays with the same endpoint. And like Nia, I think you were saying that endpoint is called or someone is saying it, the endpoint is called the vertex. And if you want to see how big that angle is, and we could measure it, and it often helps to have a circle with it. And that's what we are going to be doing that today. Okay, so thank you for not saying a corner thing or a sharp thing. These might be applications of angles, but an angle very specifically is two rays with a common point. Okay, what 9-letter word? This sounds almost like Jeopardy. On the count of three, I'd like to hear it if you know it. Who has an idea of this 9-letter word? Count of three, I'd like to hear it. 1, 2, 3.
Sokoto.
Yes, Sokoto. Right, it's not a word you would normally use in conversation. Does this word sound familiar to you?
Oh.
Yeah.
It's
Sokoto. Would you just take a moment to discuss what this word means?
hot news. Yeah. Yeah, I actually don't remember. It's like
Okay. So who'd like to tell us what is this? How are you supposed to use this word? Yes, yes.
Sine is opposite over hypotenuse.
Okay, so the sine is opposite of hypotenuse.
Sine is adjacent over hypotenuse, and then tangent is opposite over adjacent.
Does that sound familiar? Nice, thank you. Who's never used this word in their like geometry? So maybe did you learn a different way to remember what sine, cosine, tangent, or did you just learn it? What's that? Just the definition. You just learned that like sine of x is equal to opposite over hypotenuse like this. This is great. Yeah. Didn't anyone else just learn from the definitions? Yeah.
We also were up this.
And then SOHCAHTOA is a way to remember those definitions. Okay. When I was a kid, we didn't have that word SOHCAHTOA. That's like a new modern.
That's kind of like unique.
What's that?
You guys have that thing.
Oh, back in the day, let me tell you, you had horses.
Remember? The horses?
Yeah, you're on.
We still have horses today.
We had what? Yeah, we had a log cabin. We had this sentence.
Oh, scared.
Hey, what you know about?
Hey.
What you know about?
This is how I was taught to remember sine, cosine, and tangent. Will you take a moment to see if you and your neighbor could figure out how that's helpful at all?
It's a different letter, but the Russian.
The opposite. Oh. Yeah.
Back in the day, we didn't have SOHCAHTOA.
We still have horses today. It still exists.
In America? Me too, Haley. It's in the. Okay. Did you get it already? Do you need to discuss your neighbor? Haley, don't forget, you're not alone.
Yeah. Distance here is three, yeah. And then also obviously, it's just missing hypotenuse. It's not hypotenuse. Yeah. Oh wait, because I thought hypotenuse was that. I think it's a draw. Wait, hold on.
Yeah, we're gonna start doing that.
Okay. I'm not going to call someone for this, but my question is, do we know the radius of this circle? What is it? Are you sure? How do you know? It says right there. This length right here is 3, and since it's a circle, every length from the center to the circle is 3, so that is 3 as well. That's how we know that the answer is on the count of 3. 1, 2, 3. It is A, just cosine the theta is equal to x over 3. Now they're saying because the ratio of the horizontal displacement of P from the y-axis to the distance between the origin and P, it's just adjacent over hypotenuse, right? That's all you need to know. Okay, so this one, they need to tell us the radius is 5 there. Really?
No.
It seems redundant, doesn't it?
Wait,
Yeah.
wait.
Why didn't they need to tell us?
Oh, because 3, 4, 5.
Yeah, we have a 3, 4, 5 right there. Okay. So do we know the coordinates of point P?
Negative.
No, 3. 3, negative 4.
3, negative 4, is that right? Okay, so notice the angle. Do you see that angle? The angle,
Oh,
because we're talking about an angle in standard position. This is in the 4th quadrant. It's huge, isn't it? Do you see that this is a huge angle that we're talking about? Its theta is this whole thing. So I'm going to put a little arrow on the end of that to emphasize that we're actually starting at the initial side and going to the terminal side. That's the angle we're talking about. And the fact that we've developed some definitions that are no longer dependent on the lengths of sides, it's dependent on coordinates. And ask everyone to just look at me for just a moment because it looks like you're working. What this does is it allows us to abstract. Before we could never find sine, cosine, and tangent unless the angle, this angle here were acute. Does that resonate with what you've done? But anytime you're taking sine, cosine, tangent, it's always been of an acute angle. Now we can take it of any angle. So we're going to be doing some abstraction of angles out here. Like in this case, it is an angle that is technically in, well, between 270 and 360 degrees. So let's see if you can figure out the sine, cosine, and tangent of that big angle. Can you show me the sine of theta, please? Show me the sine of theta. You need to use 2 hands. If you got it, you need to use 2 hands. Nice. On the top, I need to see a -4. Is that right on top? And the bottom is a 5. Does that make sense? The hypotenuse is always positive. Now remember, the definition of sine is just y over r. So simply all you have to do is take that y value, -4, and put it over the radius, which we know is 5. And that's it. That's it. There's no other work to be done. Try cosine and tangent. Make sure your neighbor has it too.
Wait, does it matter where the y is?
Well, the y has to be from the angle that we're using. As long as we're in standard position. Okay, please show me your answer for cosine of theta. 3/5. And for tangent of theta, -4/3. You would never put the negative on the bottom.
No.
Just making sure. -4/3. And in this case, you don't have to because y is negative. Any questions about this? It may be a little bit uncomfortable to do this. Yeah. Yeah, because the definition of tangent, y/x. So we're simply taking the coordinates and putting them where they belong. Sure. Now it is weird to think because you know that tangent by definition is opposite over adjacent, yes? It's weird to think, okay, opposite over adjacent, but how does that relate to this angle? So what we introduced is something called a reference triangle, which is always created by drawing from the point, that terminal side, going directly to the x-axis and making this triangle here. This is called a reference triangle. Reference triangle. And in this reference triangle, there's a reference angle. It's also the angle between the x-axis and whatever the angle is. So I'm going to not label this theta because we already have a theta. I will label this as theta prime. And this is the reference angle. And at this point, maybe it's a little bit more comfortable to do the opposite over hypotenuse and adjacent over hypotenuse and opposite over adjacent. Does that make sense? We now have like, this is our opposite, -4/5. That gives us our sine. Something we could see a little bit clearer. But obviously, it's reference because there's no such thing as the length of -4 in a regular triangle. This is an abstraction for something that's bigger than 270 degrees. So we use that just as a reference. So keep that in mind. But really, all you have to do is this. This is a definition, sine of theta. And if you could keep this in your brain, maybe then you can remember. Sine of theta is y/r. Cosine of theta is x/r. Tangent of theta is y/x, etc. Any questions? Oh, okay. So in this case, someone's so happy they're humming. It's interesting. Me too. Okay, so we know that the coordinates of P are x and y. And since it's in the first quadrant, both x and y are positive. You please express q, r, and s in terms of x and y, but adjust appropriately.
That's -1. -1. That's -1.
Did you get it? Haley, can you tell us what you got for point Q?
-x on y,
Okay. And R?
-x and y,
Do we agree so far?
Yes.
Okay, and for S,
x on the -y.
thank you very much. So 4, 5, 6. Go ahead and do all three of these, please. You see, I marked the actual circle. I think it's helpful to do that.
So from the side.
Okay, so example 4, who'd like to test what they got? Yes, Oliver. Are we good with that? Y over R, everybody? Oh, you said negative Y? I'm sorry, I missed it. Are we good with that? Thank you. Do you know the radiuses are?
Yeah.
Yeah, it tells us. Can I call you? Examples 5 and 6, are you ready? Oh, look at this. Oliver, example 5.
Negative X over
Negative X over Y. Now this is point Q.
R.
Oh, over R. Thank you. And Max, example 6.
The tangent of the angle. So I'm a bit confused on how the y, like, so, like, I'm a bit confused on how the segments work,
How the what?
like the segment distances work.
I don't have to worry about segment distances. You could just think about the definitions of tangent. By definition,
Oh, it's just definition.
yeah,
Oh, then it's just y over x.
is Y over X. Are we good with that? Y over X. It started with negative over negative, but it changes to Y over X. But yeah, let's just take that one specifically. And thank you, by the way, for your help there. And for example 6, we are doing this angle. Does that make sense? Are we doing that one?
Oh,
Yes, Simon.
Is circle always like more, like it's below, I don't know how to explain it, but you're not going back, right?
It's always, well, from this point, we always go directly to the x-axis. Directly to the x-axis, which means in this case, I'm gonna go up to make my reference. And then here we have it. And then once we have this, and once we have this, then it's a little bit easier to do. Do we see our reference angle here?
Yeah.
It's the one that's adjacent or that's made with that x-axis. So theta prime would be right here. And then I think everything lines up a little bit easier. It becomes a little bit less abstract. We could label the sides of our triangle here as negative x, negative y. And then you can see opposite over adjacent. So I like to use a reference triangle rather than just memorizing the x's and y's, but it's up to you. Max, thank you for your help with that one. Okay, let theta be an angle in standard position whose terminal ray coincides with the line y equals negative 3x in quadrant 2. So I want you to visualize the line y equals negative 3x. Do you have it in your brain? Okay, please show me with your pencil what it looks like. Y equals negative 3x. Okay, so I'm saying this kind of thing. Okay, I'll let you do what you can. Check in with your neighbor whenever you're ready. Work out sine theta first.
fine. So, wait, what is it? Oh, it's negative 3x. Yes. Never got past this.
I got it. So that's over. You got it already?
Yeah.
Did you draw the angle? Let's make sure we drew the angle. So we have this. I need a point, don't I? Where's a point? I need a 0, 0, yes. And I need two sides. I know that the initial side is the x-axis right here. But where's the other side? The terminal side. So the second quadrant for sure, but specifically
Negative 1 comma.
negative 1 comma 3. Does that make sense? Because to get that point, maybe what you did is you went up 3 and to the left 1. Does that seem like what you did for that?
Wait,
which gives us our second side. And we just need any coordinate, the coordinates of any point on that line, which we already have. So this is -1, 3. Are we able to do the work now to find the sine, cosine, and tangent of this angle? Take a moment. If you want to make a reference angle, you may. Yes.
Why do we need to find the point? Why can't we just use that y equal -3?
Well, we need the line y equals 3x. I would, yeah, so I'm just trying to portion this line. This line goes on forever both directions.
Understand, so why did you have a point? Why, instead of like using a point for sine, could you do like -3x over r?
Well, we need numbers. This was very specific, this thing, very, very specific. We have the initial side, and it says that the terminal side, where is it? Oh, here it is. Terminal rate coincides with this line, so we need a point on this. We need an x and a y. Yes.
How do we know like the radius of this one?
Oh, yeah, that's a good question.
Radius is radius.
Right.
3x. Yeah, that's correct, yeah.
There's a lens.
Yeah, to a rational.
I'll be back up here.
Oh,
Do you want to make a reference triangle? Will that help here?
Sounds
Yeah, from this point, I go to the x-axis. So here's this, and the reference triangle is right here.
So our
So our reference angle, it's always with the x-axis. So it's right
does that
here.
mean our radius is -1? Or
I'll let you finish. You and Chip can discuss. This is -1. This is 3. You got it.
We got it, I think. Wait, something in my videos.
oh, divide 3 by the.
Who would like to tell us what they did for sine theta? Yes, Simon.
So we calculated the radius by doing the Pythagorean theorem about √10. And then for sine, we know it's opposite over hypotenuse, so we have 3 over √10.
Okay. Are we good with that, everybody?
Oh, yeah.
You never have to rationalize the denominator again, unless I ask you to. So you may always leave a radical in the denominator. I'm sorry, Shiv. I know you like to rationalize them. You can rationalize them. I'm not going to take that away from you.
Oh, sure.
Yeah, in this case, it's not really a radius. It's more of a
Sorry, hypotenuse.
hypotenuse, but you can imagine a circle that that's part of. So it comes from the definition of sine, cosine, tangent. Yeah, good. So with that in mind, is cosine theta easy to do?
Yes.
On the count of 3, let's hear it. 1, 2, 3. Nice. And tangent of theta on the count of 3. 1, 2, 3. Just negative. Any questions?
Wait, do you need a rational?
You do not ever need to rationalize again. You may if you like. Okay, and notice that this is topic 3.2, part 2. Part 2 we do on Tuesday.
So we're done.
So we are done with the lesson. So you have some time to work on your assignment. And it is in the packet once again. I think next time will be Pearson. Next time is Pearson. This time is packet.
Yeah.
Read up, 3.2, right?
3.2, part 1.
Once we're finished.